We are about to start, so please take your seat. And it seems we are already online. So cheers to everyone there in internet. And welcome to all of you here. If you missed, it's finally of a 3-minute thesis competition, so welcome you all. Just a reminder that this event is organized under license from Queensland University, Australia. And I need to check in notes because it's changing all the time, but now this event is held over in 900 universities across more than 85 countries worldwide. So yeah, we are now part of a really big international team. That's the first competition organized in Warsaw University of Technology. So thank you very much in first place to all of you who are brave enough to take part in this competition, and to all of you who helped to organize this. Before we get really to the competition, I need to say in first place that the doctoral school that organizes this event, please a round of applause for Professor Pobudkowska-Mirecka, for Piotr Salomon and Anna Poskropko that are not here. I mean, they are here, but not, you know, like free electrons, somewhere around helping. Also, IDUB. So thanks all you also for Daria Grzesiek, who's there. And we wouldn't have this transmission and all these technicalities if we won't have Sebastian Gaś and Marcin Krajewski. So thank you all for doing this. But now, this is a competition. So congratulations to all the people that are in finale. It was really hard to get to this part because already we got 44 participants in semifinals, so it was almost like in National Science Center success ratio. So it was as hard as this, so congratulations. And to judge who shall win this competition, we have our esteemed jury here. The head of the jury is our Vice President of Warsaw University of Technology, Professor Mariusz Malinowski. Accompanied with Professor Paweł Pyżanowski, a head of doctoral school. And because it's also about the communication, so Krzysztof Szymański, head of Bureau of Communication. And well-known science journalist and former student of Warsaw University of Technology, Radosław Brzuska. As a head of the jury, may I invite you to say a few things?
Okay, thank you very much. It is my great pleasure to be here. So I would like to thank, first of all people involved to organize this event. You can imagine that being here, there is only the 3 hours meeting, but behind of this meeting, it's many hours of preparations. So thank you very much for all of you. At the same time, I would like to thank all of the brave people who decided to take a part in this event. Because it's, in my opinion, it's really tough to present your research topic in 3 minutes, especially when you have no behind the slides. So even it's a tough for professors, even it's not possible, for sure. So you are on the very elite group, which we able to present the achievements in only 3 minutes. We will today we'll listen only the top 10 of those who decided to take a part in this competition. So I keep the finger crossed that the best of you will win and will represent also the Warsaw University of Technology in the next steps of the competition. It's you see that 3 minutes is really short. I think that I'm also limited to 3 minutes. So thank you very much for all of you and good luck.
Just to remind you the technicalities, we have 3 minutes. The if you haven't noticed, the timer is there. I'm going to invite you and then run the timer, and after your presentation, you'll answer the questions of the jury. Okay, so it seems we are ready, and look, we are ahead of time. We have 4 minutes ahead. Let's invite the first speaker, Idris Aldugo. Please come to stage. Idris comes from Faculty of Power and Aeronautical Engineering and is in the Environmental Engineering, Mining and Energy panel. You have... It's working?
Yes, it is.
Okay. So ready, steady, good luck.
I would love to take a guess. Many of us here today used a soap, a shampoo, or even ate a snack. Yeah? Don't worry, I'm not judging your hygiene or snack choices, but I would love to talk about the hidden environmental costs of getting these products to you. From the time raw materials are sourced to being transported for processing and even distribution to end users like you and I, this everyday product travel through a complex supply chain process that consumes massive amount of energy and emits significant greenhouse gas. Now, what if we could revolutionize this process, cutting the environmental impact without disrupting our dependency, the way we live on this product? The fast-moving consumer goods sector, FMCG, is responsible for delivering these essential products to millions of people every day. However, they are one of the largest contributors to global energy consumption and emission. There are existing tools for environmental monitoring in this sector, but they often fail to identify the inefficiencies or even address the complexities that comes with global operations. And this has left several companies struggling to balance their operational efficiency with their environmental performance. My research introduces a data-driven framework that integrates advanced analytics with global sustainability standards. So it goes beyond just monitoring energy and emissions, but also identifies supply chain inefficiencies, predict trends, and provide actionable insights and solutions to minimize environmental impact while maintaining operational efficiency. Now, imagine Reckitt and other FMCG leaders use this framework to cut emissions by 20%, reduce energy cost by 15%, while aligning with global sustainability standards. Beyond the numbers, actually, this framework empowers companies to adopt sustainability as core part of their day-to-day operation, ensuring and seeing them that every product out there on the shelf and their supply chain process leave a smaller footprint. Ladies and gentlemen, with data as the backbone of this framework, it has the potential to transform FMCG supply chain from contributors to energy problems into leaders in sustainability. Thank you very much.
So thank you very much for your presentation. There's a time for questions, some questions.
Yeah, I can ask a question.
Yes, please.
Yeah. Hi, my name is Radek Brzuska, and I'd like to ask you, what is the main goal of your research? Are you developing a new system for analyzing the impact of the supply chain, or are you analyzing existing solutions?
So thank you so much for the question. It's an intercept of the two. So I'm developing a framework. There are existing framework, of course, but oftentimes some framework just measure this energy emissions and all of that. Some just provide recommendations based on some, but mine is doing all of this together. So I'm trying to build a solution that can not only measure, but can work on this data, come up with insight, and more importantly, it aligns with the global sustainability standards regionally, because right now, of course, ESG standards vary across the region. So this also is being put in play even during this development. And so it's a mix of it's a solution that measures and also is able to give recommendations and help companies monitor their performance, basically. Yeah. Thank you.
Thank you very much. More questions? We have the ocean of time. We have 7 minutes, so it's much more than the presentation.
Okay, so I'll ask another question.
Sure.
You're saying about the local regulations and local requirements, like ETS in Europe, right?
Yes.
You know of those things, regulations in place that require businesses also in FMCG sector
Yes.
to report their emissions
Yes.
and environmental impact.
Yes.
So the problem with FMCG and transportation is that they really lack the tools. However, there are big companies and big software houses that are already there, and they're developing their software
Yes.
to comply with ETS and all the other regulations all around the world.
Yeah.
How would you plug into that system? How would you make the change?
Okay. So I actually work as a senior data engineer in one of the top FMCG companies in the world right now. So I have the privilege to have this project in sync with what we are doing. And of course, we have this system in place for the data gathering and all of that. So basically, I'm just plugging into that. And of course, trying to focus more on EU. I would be making comparison with other nations of the world, but the focus is on EU. So, and that's a bit more standardized, right? The data we have is a bit standardized, and it's actually one of the limitations I'm trying to bridge, which is why we focus on EU. So I think on that side, it's a bit resolved for me because of the privilege I have with the company. Yeah. Yeah. And my company is the case study, actually, so it's really, yeah.
Okay, thank you very much. What is your dream in relation to the outcomes of your projects?
So the most important thing for me, I think, it's being able to build a system that not only takes the sustainability side of things, but is able to leverage on data. Yeah. So eventually, I want this framework to be scalable and to be adoptable for even other FMCG companies to be able to use this framework, leverage it to try to improve their environmental footprint, basically. And I want to be a leader in this field.
Okay, thank you very much. More questions? One more?
Yes.
Maybe one short question. In the end, is consumer. Can you tell us one the most important benefit for consumer?
Yes.
Only one.
Yeah. So the benefit, of course, is across the entire supply chain. But for the customer, for the consumers, what it means is that they are using products that are more sustainable. So that's more of the impact majorly will be felt on the FMCG themselves, the company. So they are able to improve the sustainability across all their supply chain even before it gets to the customer. So basically for the customers, they are leveraging on products that are more sustainable. And of course, the environmental impact is there for everyone, not even just the customers, but everyone is impacted by this. So, yeah.
Okay, thank you very much. One more?
Okay, the last one. Okay. In your presentation, you used a few numbers, like 50% reduction of something or 15%.
20% emission
Yeah.
and 15% energy cost.
How?
Yes, so this is the Reckitt. Oh, okay, I mentioned my company. Okay, so this is actually the goals. So we have a net zero goal of 2040 and 15% reduction by 2030. So I'm basically aligning with the goal of the company. Yeah.
Okay, thank you very much.
Thank you.
Thank you.
Yes, I confess I used shower. I knew that there will be a camera here. It was important. But now we are switching to different field. Karolina Gabor-Siatkowska from Faculty of Electronics and Information Technology will tell us about where the psychiatry meets IT, a multimodal dialogue agent for patient support.
25% of Polish population has mental health problems. Every 10th Polish citizen has depression. You can say, okay, why do we even care? Let the psychotherapists and psychiatrists do their job, right? Yeah, but statistically speaking, we have one available psychiatrist per 8,000 people. And the number of people with mental health problems is still growing because we had COVID-19, because we have inflation, and because we have actually a war right next to our border. And what about the most of us here, the PhD students? What are we dealing with every day? Constant feedbacks and improvements, tight deadlines, very high expectations, and actually a great fear of failure. So isn't it a little bit overwhelming? Imagine there could be a solution where everybody who experiences overwhelming emotions could talk to someone for free without being judged. Actually, we have such a solution. It's called Therabot. It's a dialogue system. You can talk to it in Polish language. It's goal-oriented, meaning that it can guide you through a whole conversation about your difficult emotions, for example, anxiety, fear, or shame. And in the end, if you want, you can take part in a relaxation exercise to calm your emotions down. This dialogue system is a combination of many different topics in IT. For example, the automatic speech recognition module. So the system has to know that you're actually speaking to it, right? Then topics from natural language processing. For example, intention recognition. So what is the meaning of what you just said to the system? Another important topic is emotion recognition. So basically, what are the emotions behind of what you just spoke? I have implemented an eye tracker into this dialogue system. So basically, it doesn't only react to your speech, but also to where are you looking at while you're conversating with it. And why is this important? Because maybe when you're talking to Therabot, you are too overwhelmed, thinking too much about your emotions, and just don't look at the system. Or maybe you're just crying because of your emotions. Another possibility is that you just want to quit the conversation and go away. So basically, thanks to the implementation of an eye tracker, the dialogue system can respond more empathetically, more accordingly to your emotion, to your behavior, and actually be more human-like. I'm really very proud that in my PhD I can give such a concrete solution to an existing problem with mental health. And if anybody experiences of you overwhelming emotions, difficult situations, feel free to come to talk to Therabot. Thank you very much.
Okay, thank you very much for the presentation. Questions, comments? Committee members, please.
Yeah. Hi. Very nice presentation, thank you. I wanted to know, what is your ultimate goal? What do you want to support psychiatrists and psychoanalysts?
Actually, yes. We did already experiences last year in the Institute of Psychiatry and Neurology. It was the first edition of Therabot, and now we have experience, we have data, and I can integrate the eye tracker so it actually can respond more to the schizophrenic patients which were there. And now we just hopefully want to make in future another edition where it can be more like sympathetic with them and give them more support. It's actually an addition to all the treatment they receive in the Institute of Psychiatry, but actually it can be also for every healthy people, student, whatever.
Is your goal going to be gathering data or actually helping people? So it's
helping people,
helping
definitely.
people.
Helping people.
So
like for my PhD, it's of course data, but it's helping people, yes.
Is it going to be medically certified? Does it need any certification to work with patients?
I don't think we are thinking about it right now, but maybe in future, I hope.
It was exactly also my question, because I really wonder how are we going to evaluate the outcomes of the project? Who will evaluate? Some of the psychologists or also the people, the patients?
In our research, we have already a psychiatrist. She's also from cognitive behavioral therapy. She's a supervisor there, and she guided us and was working actually the whole time with us, engineers and researchers, so that Therabot is helping in each stage and it should be like a conversation not with a real human, but like almost human, when psychiatrists and psychotherapists don't have the time for it. Yes, so we are actually walking side by side, and when it comes to the evaluation, we always think about how could we help, and she's, and of course we are too, definitely interested in if really the conversations mattered somehow. So did the patient feel supported? And the answer is yes. Of course, we had many problems with the dialogue system itself, also with the patients, because they had schizophrenia, and there's really a quite variety of how you can behave, but still it helped people, and we're hoping that it will be helping in the future.
Okay, thank you very much. I guess that also some of the artificial intelligence is embedded in the project.
Yes.
How much?
In this edition, we used, for example, Google BERT for emotion recognition, of course enhanced. And in the future, we are thinking about doing it with GPT models.
Okay, thank you very much. More questions?
Is it safe in terms of reactions to what patient says or how they behave? So aren't you afraid that the system might say something that could make the patient confused or angry, or some bad advice like go and kill yourself, whatever?
Actually, I'm not afraid, because first of all, we have the supervision of our psychiatrist. And second of all, GPT models are getting better and better. Of course, if you talk to ChatGPT, sometimes the outcomes are really different and you don't know why. But actually, from time to time, we did the analysis and the research last year, and it was about ChatGPT 3.5, yes. Now we have 4.0. It reacts in another way, and we can enhance it. We can actually tell the system, we can tell it by code how it should react. So actually, I'm not afraid of it, no.
I will continue it because it's also the matter of the accuracy. I think that having the 1,000 of the patients or 1,000 of the people using this software, I think that will be at least one situation where it will be not recognized properly. So what in this situation?
We are like now in the task of developing, and when we are going to test with healthy people, yes, then we have to think about such problems that, of course, we know that they will come. So it's kind of the answer is we're working on it, and we know that this might be crucial when it comes then to giving it to the patients.
Any question? More question? Because we still have 1 minute. Okay, so we save this time. Thank you very much.
Thank you.
Thank you. And the next speaker is Natalia Izdebska from Faculty of Chemistry. Right?
If I had to sum up my PhD in 4 words, it would be batteries will be better. I work on batteries, which everyone uses every day. You certainly know the feeling when, during an extremely important scrolling session, your phone gives its last beep and discharges completely. And maybe you wonder, why do electric cars have such bad PR in Poland? It's because you cannot drive from Krakow to Gdańsk on a single charge, and there are either few charges on the way, or they're all occupied. But what if I told you we can only charge our phones once a week? Or what if we could buy an electric car that would allow us to travel half of Europe on a single charge? This is exactly what the research in my PhD will be used for. Currently, all batteries are based on lithium. It's very expensive. Batteries, let's be honest, do not have the highest capacities. They work for a short time. They quickly lose their original lifespan. My solution to these problems is magnesium. Magnesium is the 5th most common element in Earth's crust. We have high probability that there is magnesium in the sand that we brought here on our shoes. Everything would be great, but magnesium batteries do not want to work. Why? Magnesium is not such reactive metal as lithium. It undergoes passivation. That means it's covered with an insulating layer on the surface. It would be best if the charge in the battery was carried by ions. Magnesium doesn't want to disintegrate into ions. It has 2 positive charge, which is hard to maintain in a battery. But this is where my research comes in, all in white. I add supramolecular compounds to these non-functioning magnesium cells. Such compounds are huge organic structures that we, chemists, can build from chemical blocks like Lego bricks. From Lego, you can build huge pirate ship or Mercedes G-Class, and I can build these fancy chemical spheres. My molecules promote the formation of Mg2+ and act as tunnels for them. Thanks to this, without any external interference, without passivation, the ion carries the charge in the battery. It's a bit like having as many lanes on a highway as there are currently cars on it, so that everyone can reach their destination without the need to overtake, traffic jams, dangers. A little spoiler, it all works, and I hope that in a few years I will have a smartwatch powered by magnesium battery on my wrist. My name is Natalia Izdebska, and remember me when you get in your magnesium battery-powered limo.
Okay, thank you very much. Questions, comments from the committee? Of course. Yes.
If I could, thank you. Well, great presentation, thank you. I was wondering if that is so easy, why isn't it available on the market yet?
Well, you know, the magnesium batteries without the additives only work for like 6 cycles, 6 discharge and charge cycles. With additives, we can make them work up to 200 cycles, and the lithium batteries can work up to 3,000 cycles. So this is just preliminary research. And I actually have a little small fun story to tell about it, because like last year or 2 years ago, we had Stanley Whittingham visiting our university, and he's a Nobel Prize laureate. And I myself asked him a question, what do you think is the future of the batteries? And he told me, well, if you are working on magnesium, then just let it go. It won't work. And I want to prove Mr. Stanley Whittingham that we can make it work, actually. And I think he also heard when he was working on lithium, like, let it go, it wouldn't work. And I want to prove him that, yeah, we can make it work, and I can make it work.
Well, you said you did make it work, that it works in your lab.
Yeah, it works, and I want to make it work even more, you know, to reach maybe 1,000 cycles, so it could be usable in a smartwatch, smartphone, even an electric vehicle.
Wonderful. I hope you will be the next Nobel laureate.
Well, I would love to.
So I guess that we'll have this 1,000 of cycles next year, or?
Maybe not next year, but maybe when I reach the end of my PhD thesis, then yeah, I hope.
Okay. More questions, comments? So what's the current capacity of this battery?
Oh, right now it's not that high, but it's still higher than lithium. With lithium, we have about 300 milliamps per battery, and with magnesium, right now we are going up to 500 milliamps per battery, but the theoretical capacity is much higher, so we tend to strive for more.
How much state of charge has influence for the lifetime of such battery?
You mean the state of
charge? How much you deeply discharge your battery? Yes, because you can discharge to this almost to zero, and you can discharge to the 70% or 50%. And in case of the lithium-ion batteries, it has an influence. But how it's in case of the magnesium? Sure,
it also influences the magnesium batteries, but this is just preliminary research. And the state of charge tests need to be conducted when we know all about the chemistry in a battery, or we know how it works. Right now, with magnesium, we learn about its chemistries in a battery. So I guess these are the next steps in working on magnesium.
Okay, thank you very much. It's a last chance to ask the question.
Okay. Okay. So if you said you're so committed to developing that technology, what would have to happen for you to stop developing it, working on it?
Someone would have to maybe not sell me magnesium, because I need some magnesium to work on magnesium batteries. So if they stop supplying it, then maybe I would stop. and switch to a different metal.
So no research results will stop you from researching further?
No, actually, my whole 1 year was a total failure. I actually didn't make it work for the first year, but right now I'm just starting to kick it off.
Wonderful.
Congratulations, thank you very much.
Thank you.
And please applause again. And we move to the next speaker.
Yes, thank you very much. And now we'll invite Shama Kahir Allah from Faculty of Power and Aeronautical Engineering.
Thank you. Good evening, everyone. My name is Shamma, and for the last 3 years, I show up at the explosions laboratory every morning and try my best not to blow everything up. How, you may ask? Well, using water liquid spray systems. We all know by now that hydrogen is the green future for our fuel industry. However, in case of any accidents, hydrogen can have catastrophic consequences to infrastructure and to people's lives. And that is where my research idea came from. The idea is not to flood everything with water, lose valuable, expensive equipments, but to use as minimal water as possible to fully mitigate 3 main combustion phenomena, which are laminar flames traveling at subsonic speeds, slow speeds, deflagration, which is a shock wave followed by a flame traveling at subsonic to sonic speeds, and finally, detonation, and most catastrophic of all, a shock wave coupled with a flame front traveling at supersonic speeds. So theoretically, there should be matrices of properties for a water droplet cloud that would enable us to mitigate these 3 combustion phenomena. How to test that experimentally? That's what I am doing using a 6-meter tube. This 6-meter tube consists of 3 main parts. The first part is the acceleration section, where I ignite the flammable mixture and allow the flame to accelerate to generate a shock wave if needed, and based on the number of obstacles, I will get a specific flame and shock wave velocity. The second part is the water connector part, which I introduce the water droplet cloud to inside the tube and enable the interaction between my combustion and the water droplets. And finally, I will have ion props and pressure sensors located along important locations of the tube and will enable me to measure the velocity of both the shock wave and the flame. And by comparing these velocities before the interaction and after the interaction, one can assess the impact of different clouds of water droplets on these combustion phenomena. But before each test, these water nozzles are tested in an identical cross-section of the tube to confirm the properties of this water droplet cloud. So finally, what I am trying to do is to find 3 main properties, matrices of properties, that would enable me to fully mitigate laminar flames, deflagration, and detonation. Thank you very much for your attention.
Thank you very much. So I open the floor for discussion. Questions, doubts?
Okay.
Doubts?
No doubts, no. Thank you for a wonderful presentation.
Thank you.
It was actually the first one where you very precisely explained what the methodology is of your research. So thank you for that. You didn't explain what the pictures are showing on the bottom, because I understand the schematics of the pipe. I understand the 3 ideas of the waves with subsonic, supersonic, and all that speeds, but what are the 3 pictures there?
This is the cross-section of the tube that I used to test the water droplets nozzle and confirm the water droplets properties. And so using a speed camera, a high-speed camera, and a backlight, a very strong backlight, we take pictures and we analyze it. If we would like to analyze it more, we did that using a laser diagnostic system too.
So the one thing I did not understand from your presentation is, why are you expecting this to work? What are the expected results? Why water? Why not a thick wall of concrete or anything else?
Well, with water, it's very cheap. It's everywhere. It's very easy to install. And theoretically, with detonation and deflagration, there are specific properties of a water droplet cloud that would enable me to fully mitigate them. But they have not been tested yet. And that's what I'm doing. I'm testing them at the moment.
So ideally, if this works, could be used as a water curtain in some critical installations?
Exactly that.
Okay, what's the state of the art in this field currently, and how much your solution move in this field research?
Okay, for now, the state of the art, not much has been done using, especially detonation, because it's extremely dangerous. So what I am trying to do is I am trying to contain the detonation in a shock tube. And by moving with slow velocity increments of the detonation, because it has different velocities. It can be weak ignition or it can be strong ignition at sonic or to supersonic speeds. And I am trying to go in increments and find at each shockwave velocity what would be the water droplets properties that would be enabled to mitigate. So it's a big matrix where you have, it was never tested before.
Okay, thank you very much. Questions, comments? I look for the committee. No? Jury? So thank you very much.
Thank you
Applause
very
for
much.
you. Thank you.
Thank you. Thank you. Yes, it's legal to speed up. It's illegal to go over the time. So we are great when it comes to time. So let me invite Joanna Konopka from Faculty of Chemistry about lab-on-chip microplatforms.
Let's start with a simple visualization. You can close your eyes and imagine Luxembourg, apparently one of the safest countries in the world, with beautiful landscapes and approximately 700,000 of people. From the statistical point of view, the whole population of Luxembourg may die within a year due to breast cancer disease. The predicted statistics related to breast cancer mortality are making the blood run cold. Why? Because approximately 80% of tested drugs are being rejected only at the third stage of clinical trials. In other words, 80% of patients that participated in those clinical trials have been treated with ineffective or even worse, harmful drugs. Those clinical trials have already been performed by global pharmaceutical leaders such as Sanofi and Pfizer. Their failure was mostly due to the lack of the appropriate in vitro drug testing models that neglect such important cues as the vascularization and inter-organ communication. Cancerous vascularization and its subsequent angiogenesis are indeed one of the key factors contributing to the development of tumor masses, their metastasis, and the drug resistance. Therefore, the key objective of my research is to develop an in vitro micromodel, including breast tumor microenvironment and a liver microenvironment, separated from each other by a vascular barrier. Hopefully, those three cellular micromodels will be connected by self-assembled vascular network that reflects the in vivo microenvironment and will allow the analysis of the eventual therapeutical side effects of tested compounds to the liver. A ready-made microplatform will consist of two layers. An upper layer is a PDMS cast. It's a transparent polymer within which the microstructures for the cell culture will be patterned with the use of a 3D printed resin mold. Then a PDMS cast will be bonded with a microscopic slide to provide an appropriate imaging of cells. The whole microfluidic platform has a size of a paper clip. Then three-dimensional cellular micromodels will separately be developed and gradually incorporated within a microplatform. Every experiment will be followed by microscopic observations and biochemical assays such as ELISA and PCR to quantitatively assess the angiogenic alterations. Overall, this described project is a response to a call for more advanced breast tumor in vitro models. Hopefully, the findings of our team will contribute to the development of more effective, even personalized treatment. Thank you.
Thank you very much. It's time for questions.
Great presentation, thank you. I think it was a great introduction telling us what the problem is. When you started talking about the lab on chip, what I missed was that if I hadn't known about other research, I would think that this is something completely new. So you didn't refer to the technology or the idea of lab on chip, which is on the market. And I think it's very widely used on the Warsaw University of Technology as well, because when Cezamat was founded a few years ago, one of the major projects there was developing lab on chip. So I would like to know, what new things are you introducing to that method of research?
Most importantly, the most common platforms concern organ on chip. Well, here we've got a multi-organ on chip. So what is, thanks to the combination of breast tumor with liver, we can also see whether there are any side effects to the liver. We can also try to verify whether the liver, if we use prodrugs, whether liver will activate them or not really. So what is innovative about this platform is that there is a connection of few different organs, and then there is also vascularization, which plays crucial role in cancer development. And that is neglected in most of the platforms, and it's pretty difficult to reflect it.
So if that was my presentation, I would stress that very, very hard, that the thing that we introduce in our project is this, this, and that. And that is something completely new compared with other research based on the same technology. Because this is groundbreaking, and now I understand the true value of your project. So thank you.
Question, comments? So I have a question. If you can compare it to another, methods. So if you can distinguish any disadvantages or drawbacks of your method, because it's also important doing the research that you can distinguish them.
I think that it's pretty hard to make it repetitive, because we want, because cells are the living organism, and every experiment it's difficult to have exactly the same conditions, exactly the same parameters to continue every experiment. But as we want to also make personalized chips, I think that the repetitivity will come as well.
Okay, thank you very much. If there's no more questions, so thank you very much.
Thank you. If we speed up, simply the jury will have more time in the end to make the final decision. Now, let's move on to Radosław Maksymiuk from Faculty of Electronics and Information Technology about the passive radar. So,
military radars are usually big, complex, and very expensive machines, costing hundreds of millions of zlotys. Now, imagine a small drone that costs at most a few thousand zlotys, flying up, dropping a bomb, and destroying it. This is a significant problem for radars, that while they detect targets, they also reveal their position to the enemy and expose them to the attacks. Why is that? Let's recall first how the radar works. It transmits a signal which got reflected from the target and goes back to the radar. And by measuring the delay and Doppler shift of the signal, we obtain the distance to the target and its velocity. So you see that the radar, to work, must transmit a signal. And transmitting a signal is like announcing, "Hello, I'm here," because with current technology, localizing the source of the transmission is not a problem. And here comes the idea of my research, the passive radar, which is practically impossible to localize. Why? Because it's passive. It does not transmit any signal. Wait, what? You just said that there is always transmission needed. Now you say that there is no transmission? You are correct. But this clever type of radar really does not transmit anything. Instead, it relies on some other existing sources of transmission, like television or radio. Let me explain it this way. Do you watch television sometimes? Yes, no? Your parents surely do, so you can imagine that you're sitting in the living room, watching a film or news or football match, and this thanks to the signal sent from the Palace of Culture and Science. And this signal reaches not only your TV, but also, for example, a plane approaching here at Warsaw Chopin Airport. So we can place our passive radar here at our campus with one antenna pointing to the palace, second to the airport, and by comparing those signals, direct and reflected, we detect a plane. This is how it works, and it works so well that the TV-based passive radar is now being implemented in Polish army. The idea of my research is to explore totally new illuminator, the 5G network, which hasn't been used for these purposes before. The principles are pretty much the same, as you can see in the slide, but there are clear differences. For example, it offers better radar resolution thanks to the wider bandwidth, but there are a lot of challenges because of the standard specification. And my role is to identify those challenges and solve them by proposing some new signal processing algorithms. Thank you.
Okay, thank you very much. Question, comments? Maybe I will start.
Yeah, sure.
Because the passive radars are well known until now, yes, because there is strong research, I think, in our Warsaw University of Technology in the field of passive radars. So I think like a brand of our university in this field of radars, they are passive radars. So what's absolutely unique? Because I think you dedicate a few minutes or a few seconds for description. What's unique in your case in comparison to the previous research which was done in our university?
Yeah, I decided to spend this time because I think it's not easy to understand. Yeah, this is a new illuminator that hasn't been used for this, and because of that, because this is like 5G is a telecommunication standard, yeah. So it's not optimized for radar purposes, and like my research is to identify those challenges. For example, if the television is always broadcasted, if you have your TV switched on or off, it's always being sent. And in 5G, it strictly depends on the demand in the network. So now we are not using smartphones, I guess, no download. So the traffic is really small, and this is a problem from radar perspective. And if there is a huge download, it's good from radar perspective, let's say. And for example, my role is to deal with such challenges. There are a lot more because this standard is optimized for 5G. So it's like, my role is like that. But 5G is very promising, I would say, because of the wider bandwidth of the signal. So it promises really significantly better radar resolution. So it's, I would say, it's really worth to dive into this topic, because with television, we have now resolution about a few kilometers. And we can make it really smaller to some meters. So we can distinguish smaller objects. We can start thinking about imaging of imaging objects, the recognizing what type of object is flying. With TV, we can only see that there is something flying. Yeah, because of this big resolution, let's say.
But what's the minimum power of the signal? Because there are some of the regions with the very weak signal of 5G. So then how you can use your radar?
Yeah, it strongly depends on the power. We cannot control it, but still it depends on the application. I focus on the military application, so we would need longer distances. And for example, 5G has this part of the rural coverage with lower frequency and longer ranges. So we can use this for, I would say, tens of kilometers. In fact, there are a lot of factors to consider because, for example, 5G antennas are usually tilted down because the operators want the coverage on the ground level. From radar perspective, it's not okay, but we can think of some cooperation between mobile network operators and, for example, army. And we can think of intentionally make it without a tilt in order to extend the range, for example. But just to sum up, we can think also about another applications, for example, short-range application to protect, for example, airports or critical infrastructure, and several tens of meters is enough with the cells that we have in a city.
Okay, I will occupy this slot of the time. So I have another question. Do you use any artificial intelligence image recognition? Because if you have the radar, image, then are you using some of the artificial intelligence to recognize the object?
Not yet, because we started with detecting a car. Then if there was a success, we moved to drones. Now I'm able to detect the drone. Then there are next steps, for example, putting the radar on moving car. And now we have first synthetic aperture radar imaging. So the next steps would be to continue with these images and the recognition.
Thank you for your presentation and all the explanation. I think that your presentation would be much more clear if you worked a bit more on your slide, which is very basic. So instead of explaining how reflections work and how you can capture them and detect objects based on reflections of existing signals, you could show it on a picture, which would be probably much more clear. I wouldn't use the Doppler shift or illuminators as the words in that presentation. So like sources of signals or antennas instead of illuminators. I know this is the professional term, I understand that perfectly. But this is what I think could improve the quality of your presentation, to make the slide much more clear and communicative, so that you wouldn't have to concentrate on explaining how this works, but you could say all the things you told us now in the main time of your presentation. But it's really cool. It's really an interesting technology. Thank you.
Okay, thank you.
Thank you. This is last opportunity to ask the question. Oh, Professor Pejanowski.
One question: what is what do you think? What is the resolution of your system? Approximately, but I know that
some meters, tens of meters. It really depends, because 5G allows for different bandwidth, and it depends on the bandwidth. So we can have 100 megahertz, and I think we would have then 3 meters.
And
but for example, the currently deployed 5G networks in Poland has smaller bandwidth, so the resolution is also smaller.
Okay, and the second question, for example, here, how many base stations in your radar you can resave in the same time? Now, here, for example.
Like it's for one. I would say that the radar station is in the coverage area of one base station.
But 5G station, I think that you can receive not only one, but few. No. You used only one, but I think that you can receive a signal from more than one. Yeah.
Like usually, to avoid interference, there is in one area the signal from one base station. But for example, I encountered such situation that I recorded the signal here at our campus, and I saw that there is some signal, presumably not from this antenna at faculty that I wanted to record. So sometimes it happened that the signal from another base station reaches the radar station, but it's not useful.
So thank you very much. We pass a lot of time for the discussion. So thank you for your presentation, for your time. Applause, please. And we move to the next presenter.
Yes, step after step, and the next step is for Shirayum Monira from Faculty of Physics. Need a pointer? No.
Have you ever wondered where all the matter of the universe comes from? To find the answer, we have to go back in time 14 billion years ago, when matter existed in the form of quark-gluon plasma. In nature, quarks and gluons are always bound inside hadrons, for example, protons and neutrons. But at the time of the Big Bang, the extreme conditions was enough for these quarks and gluons to melt free of proton and neutron and move freely. This quark-gluon plasma later on expanded for 380,000 years through a process called hadronization to give rise to the first atoms, the building block of matter. My research aim is to study and understand this hadron production mechanism by studying strange particles. And these particles are called so because they have a non-zero strangeness quantum number that describes the particle decay under strong force. However, to study this, we need to recreate the conditions of the early universe, and this is done at the Large Hadron Collider by colliding two beams of protons at near light speed. I am part of the ALICE collaboration that has a specialized detector at one of the 4 interaction points of the Large Hadron Collider ring, recording a record 1 million proton-proton collisions per second. During these collisions, the quarks gain energy, excess energy through stronger interactions, and it results in very highly energetic showers of particles called jets. These jet constituents travel together in space and can be measured with two-particle angular correlation, that is basically the relative angular distributions of particles. And looking at the shape, we can study the underlying physics phenomena, for example, electric charge, conservation laws, and many more. In my studies, I calculate the two-particle angular correlation for strange particles using the data from ALICE detector, and then I try to experimentally constrain the hadron production mechanism. I compare my results to models to also test different theoretical descriptions. The results from my analysis show a striking effect. It seems for all the pairs of particles with identical baryon number, which is a conserved quantum quantity, we see a very clear depression instead of a peak. And this is not explained by any existing models so far. So there must be, or some kind of unidentified mechanism that suppresses the production of more than such a pair. And my doctoral thesis tries to explain this in terms of baryon production mechanism. With this extra step, we go one step closer in understanding the elusive nature of strong force, because this is still one of the biggest puzzles in physics. Thank you.
So thank you very much for keeping time and the questions, comments.
Yeah. Hi. Thank you for your exceptional presentation. I think so far you had the hardest task of explaining what you're into here, because theoretical physics is just, it's magic. absolutely magical for most of us, but it's very hard to explain. So when I was doing science programs, popular science TV programs about theoretical science, which I'm not an expert in, I was telling tales. And this is pretty much what you said. But I think you could reorder the blocks of your presentation to make it really engaging. So the thing you said last, where you said that we've discovered something that should not be there. Look, this should look like this, but it looks something completely opposite. This should be almost the start of your presentation. So the story about the Big Bang, and this is all okay, and now we're studying this, and we've discovered something that's not predicted by any existing theory. And I did this on my doctoral studies, and nobody expected this would happen. And now we will be investigating why this is happening. And then the story continues. But I think it was very well told, so congrats.
Thank you.
So what's the status now of your projects? This is on the experimental level now, or there's just analysis? It was not clear for me.
So right now I have already some approved results for strange particles like lambdas, all pairs of them with protons. And I'm now analyzing for omegas and psis, like the more that have more strangeness, to also compare like if the particle flavor, like the strangeness itself had some kind of effect in this process. So that is why I particularly explained like why strange particles, because we want to see if the particle flavor has something to do with this anomaly that we observe. And then in the thesis, I'm going to highlight what could be the possible explanations by taking into account all the different strange particles with like more strange, like lambda is like less strange compared to like omegas, and psis, and the psis are less strange compared to omega. So yeah.
Okay, thank you very much.
From my experience as a journalist talking to many scientists, is that I could be talking to a very, very well-known and very experienced scientist, very experienced in their field of expertise, and they have no idea about other fields of expertise. So they're really great in what they do, but they have no idea about the world other scientists are talking about. Now, when you're talking about flavors, I don't know how many theoretical scientists, theoretical physicists we have here, but probably most of the people, even here in this room, do not really know what the flavors are, what the particular names of the strangeness of a particle, what it is. So I would instead use like the qualities of particles, or properties of particles. There are some properties that we are investigating. So we chose some particles based on their properties or qualities or whatever. Just drop using all those very quantum physics jargon so that you will be understandable by everyone.
Yes.
This is my
this is the reason I avoided using the word flavor during my presentation. And
oh, you did?
I focused on strangeness quantum number.
Still.
Because that is exactly what is actually changing the entire thing. But if we think in a more bigger scale, why different strange particles, then the other quantum numbers also come into play, and it will be very interesting to see. So I really want to expand my research to give as much of a plausible explanation for the theorists to upgrade their model. So this is something, it starts from strangeness quantum number, but slowly it goes in higher in hierarchy for more strange particles, let's say. So what I meant by the lambdas have like one strange quark compared to the psi, and then omega has 3 strange quarks, so they are more strange compared to, let's say, psi. So this hierarchy is very interesting to study, because that is what we want to see, if it is actually affecting the process. And that would actually change the entire understanding about the hadron production mechanism. Because right now, none of the model can explain what is happening. They always show a peak that we are supposed to see. But in all these pairs we see a depression, very clear depression.
You see, even now you're falling back to that crucial thing you should have been starting with in your presentation. We see the peak instead of the valley, so let's stick to that, because it's like, it's chilling. I see my hair rise on my back. But when you talk about strange particles, people's minds, people who are not specialists in quantum physics, they are like, Why are they strange? Are they strange for physicists? They don't know. It's just a name of a property. So don't say strange, because for many people, this is like they stop listening to you and start imagining those particles. Do they look like cats or cows or dogs? Is it because this is why they're strange? So don't talk about flavors or strangeness. It's just, it will just derail people's perception. But the story is great.
Thank you.
Usually such research is based on the big collaboration and how it looks in your situation.
So ALICE collaboration, where I'm a part of, has 2,000 scientists working. And in our nuclear physics division, we have our own ALICE group here. We particularly study the proton-proton and also lead-lead collisions.
And who is your closer collaborator? Besides of the supervisor, of course.
The closer, of course, the supervisor, and also I have like some of my colleagues here with Daniela, and yes, so we have a big team of people, and we are looking at different characteristics of the particles. So some of them are studying femtoscopic. That's a bit similar as to particle angular correlations, but with a bit different kind of tools they're using. And then some of them are also working with the particle mass. So what happens if the mass of the particle is changing? Do we see similar effect? So we are, as a big group, I think we have about 10 to 12 of us in the group, and we are like looking at the different characteristics or the signature of the particle. I'm looking at the strangeness, they're looking at the femtoscopic signature, and some of them are looking at the mass. It's a pretty big group. I think we are the biggest in Poland working in this collaboration. Yeah.
Okay, thank you very much. In 3 seconds, we passed 10 minutes, so thank you very much.
Thank you.
Thank you. No, strengthen, I thought strange. Aleksandra Pisarek from Faculty of Chemical and Process Engineering. The floor is yours. How to strengthen the air?
Okay. Good evening, everyone. My name is Aleksandra Pisarek. So, what if I told you there is material that can reduce your heating bills? And the same material can mute the sound of your neighbor during renovation at 7 a.m., or improve the safety of firefighters, or even enable the faster space exploration. And on top of that, a material that is almost 100% of the air. Hard to believe? Here you have a picture of it. It's called Aerogel. I could go on listing its potential applications, but 3 minutes, it's definitely not enough time. So what is stopping such promising improvement in our living? Despite extraordinary nature of aerogels, they have 2 major drawbacks that stand between us and a better future. Unfortunately, aerogels can be very brittle. Their fragility also makes it necessary to use expensive methods to produce them. Aerogel is made from a gel. Yes, you can even make it from a jelly. But how to do this? In the structure of the jelly, you have liquid. After all, you create it by mixture with water. To make aerogel from it, all you have to do is to get rid of this liquid and replace it with the air. So, dry it. Unfortunately, simple drying can be very harmful for a jelly. But rather few of us tried to dry a jelly, so here's another example. What happens when you make dried mushrooms or fruits? They shrink and break. My proposal to turn down this wall? Double cross-linking. To explain it simply, when creating an aerogel, you can choose from a lot of compounds. As I said, you can even make it from a jelly. The secret of double cross-linking is to choose the compound that will have a special chemical group in its structure, for insider's vinyl group, that can be connected with the many of the same groups together by a process called polymerization. Polymerization is nothing more than building a long chain from small parts by connecting them together. So if we create an aerogel that will have such additional chains in its structure, it will increase its strength. But how is it related to a drying? As I said, as you already know, simple drying causes shrinkage and cracking. But what happens if we strengthen the structure enough? After drying, it can return to its original dimensions, just like a spring. So double cross-linking can enable the use of cheaper drying method. In summary, Double cross-linking is the future technology that can make aerogels stronger, reduce their production costs, to make them more accessible for each of us. And this is what I'm finding for in my PhD. Thank you so much.
Thank you very much. It's time for questions.
So, great presentation, thank you.
Thank you.
So aerogels exist for, what, a few decades now?
Actually, they exist from 30 years of last century, so 1931, and they not been developed so much because they have a lot of production costs, especially this drying method, which is used, can be expensive. And so the research team decided to use the compounds that can make less cost of production of aerogels, and this was around beginning of this century. So yeah, 2 decades they are developing so more, and yeah.
And how is your method going to improve the already present methods on the market?
This method improved the already present methods because many of the methods of strength and mechanical properties of aerogels often caused the structure parameters of this material. For example, they have lower densities of, or much less surface area, and this method don't cause these structure parameters, so it can be more efficient for these materials.
One more thing. Maybe there will be more questions, so I don't want to take others' time. But I wanted to say that it was really good for you to construct the presentation in a way that you've shown how aerogels could be used, and then you explain every complicated term you've been using in your presentation. So you said what polymerization is, and you've explained many other things. The jelly example was perfect. So I like the way you presented the idea and the methodology. So thank you for that.
Thank you so much.
Thank you very much, but those applause was not for me, I think. My question is, because you said that one of the factor is cost, and how much the cost should be reduced to make this material more attractive?
Can you repeat the question? Because I'm not sure if I understand it right.
Yeah, I ask because you told that one of the factor that why this the attractiveness of the material was not attractive till now, it was the cost.
Yeah.
So how much we need to reduce the cost to improve the attractiveness of the material?
Yeah, the main factor I'm dealing is the method of drying, because this can reduce cost so much, because nowadays for produce the aerogel in the form of monoliths, not cracked, and so on, we need to use the expensive drying method, which is known as supercritical drying. And if we strengthen the elasticity enough, as I said, we can use the normal drying, so ambient pressure drying. So only the increased temperature for drying these materials, and we can obtain the monoliths, nice aerogels. So this is the main factor to decrease these costs, the drying method, and that's what I'm working on. Now the type of compounds, because I use the one type of compounds, because as I said, I need the vinyl group in its structure, special chemical group in its structure. So I'm focused on that, but drying method is the most important to reduce these costs.
Okay, thank you very much.
Thank you.
So let's say you're going to succeed, and I wish you do succeed. How is it going to look in the future? How big are the monoblocks going to be, the solid blocks? Are they going to be encased in, you said that it's a good material for isolating acoustically from your neighbors. So would we put it in between concrete walls, or would we have like panels? Or bricks? How do you imagine this would look like in the future?
It's hard to imagine one type of these materials because we can have it in bigger blocks, in, I don't know, something like blankets even. So yeah, we can have it in the windows as a normal glass. So except normal glass, we can have the block of aerogel. So I think the most important thing is to adjust to the size of aerogels for each application we want to go in.
So what's the status of your research now? When will you be able to buy such bricks?
I also hope that at the end in my PhD. But the state of my research, there are two types of these methods. I don't want to talk about it much because it's a special word and something. But I'm in the middle of my research. I researched the first half of this method. And this was the, I can say, less costs part. And now I'm focusing on the part that will be a little bit more expensive, but can obtain the more mechanical strengthened aerogels. So now I focus on the part that little bit strengthen the properties of aerogels, but will be less cost. And now I'm focused on this other part that will more strengthen properties and a little bit more cost, but we can choose from these methods which we are focused on for applications.
So we have 30 seconds for applause to fill in the rest of the time. So thank you very much.
Thank you so much.
Thank you very much. Okay, and now Paweł Romańczuk from Faculty of Chemistry will tell us about brain on chip.
Good afternoon, everyone. Depression is a silent epidemic. It affects up to 350 million people worldwide, including 4 million people in Poland. That's 25% more than number of cancer cases. And it leads up to 1 million deaths annually, so every 40 seconds, somebody's taking their own life. And of course, we can treat depression, and we should treat depression. We use medications, psychotherapy, but there is also a treatment-resistant depression, where we need more complex methods. And for that, we don't know exactly the exact mechanism of work and the side effects of antidepressants. For now, we are relying a lot of animal models, but they are not really perfect and they are very expensive. And my cat Scarlett said, "Sorry, you have to leave my mice." And as well, almost 50% of antidepressants fails in the first clinical stage. So here my research comes and using innovative brain-on-chip technology, which allows to recreate the small parts of the brain in a microenvironment, which is easy to control. I'm recreating the neurovascular unit, which is simply the barrier between the blood and the brain. So this method is both technical and biological. So I first start with, it all starts with the idea. I'm creating the geometry. So you can imagine that you have created very lovely gingerbread molds, and then you are creating this using 3D printing or micromilling. And instead of using the dough, I'm using the polydimethylsiloxane, which is a transparent polymer, perfect for optic checking in. And then I'm baking it. So after that process, I'm getting the ready microsystem from the mold. Next is the biological stuff. So first I'm recreating the blood-brain barrier. So using a special techniques, I'm creating a 3D vessel, which I'm covering with the astrocytes and pericytes, and of course the endothelial cells. So the basic cells that are creating the blood-brain barrier, which is a very strict barrier. I'm also inducing an inflammatory state using the hormones, because that's the state that's in the people with the depression. Next, I'm incorporating the neurons, which will be coming from the patients with the depression, but also with the healthy patients. And that's the ready microsystem, the neurovascular unit. Also, the cells are hanged in the hydrogel, so this is the same like a jelly. And this model will allow us to check the permeability of the antidepressants on the blood-brain barrier, but also check the effects on the neurons as well as the neurotransmitters. And in the future, we are planning to connect this with other organs to check the side effects. Thank you.
So, perfect time. Thank you very much. And I also would like to notice your shirt, including also some of the elements from the slide.
Yes, yes.
Okay.
That was the idea.
It's time for questions.
Do you believe, great presentation, by the way.
Thank you.
Thank you. Do you believe you can see depression? Is depression a physical condition of our brain, not something on a different level of interconnectiveness of neurons, maybe some deeper structures?
That's both, but I have focused on blood-brain barrier because that's the main. If we don't know the permeability of some antidepressants, we won't know if it's effective because it won't reach the aim. So the next parts, like neurons, so it's very important to check the permeability. That's also a very common problem because like producers of the drugs, they don't give us any information what's the permeability of their antidepressants through the blood-brain barrier, and then that's why it's very important to check it out. And in the neurons, we will be able to see if there are changes in neurotransmitters, as well as the calcium ions, and many other stuffs.
Okay, so that changes what your presentation is about. I thought you were talking about helping the research on depression or helping develop drugs that deal with depression, but you're creating, which is great, but I think it wasn't stressed enough. You're creating a model which actually tests whether the chemicals in the medicine are getting through the blood-brain barrier into all the structures of our brain. This is the main point of your research, am I right?
Maybe not really. That's one of the points. The other points, that's also why we'll be working with the induced pluripotential cells from the patients with depression, as well as the healthy patients, to check the effects on the antidepressants. So in a cooperations with Institute of never mind. We are doing this, and we will be checking some possible combinations of new antidepressants. So my aim is actually to check the psychedelics as well as atypical antidepressants, but it's really hard to get all the allowances to test those drugs. So that's the thing I'm working on, and that's going to be in the future. But it's not only about checking the permeability. That's important, but that's why there is a full neurovascular unit, not only a blood-brain barrier.
Okay, so if I were you and I was trying to explain what I'm working on, I would say that what we want to do is to focus on creating as good of a model as it's possible to simulate the environment in which the medicine created by other companies, not by us, but by other companies or suppliers, how well it goes through the barrier and how it interacts with brain cells. And this would give me a clear idea of what you're researching. And this is where you could, get your story going from. Because the way you started this presentation was like you wanted to treat depression. You wanted to develop the chemical compounds that actually interact with brain cells. So if you were working on any other type of drugs that do work in our brain, it would still be fine. Your research is still suitable for that. So depression is just one of the ideas, but it could be anything that goes inside your brain and interacts with its cells, right? You focus on depression, but as I understand so far, I might be wrong,
Maybe not at all. Of course, we can use this model in the future for some other illnesses like schizophrenia or other stuff. But here I focused on creating especially this an inflammatory state in the blood-brain barrier, because that's connected to the depression as well as those induced pluripotential cells from the patients with depression. So yes, there is a lot of variety with this model, but I actually wanted to focus strictly on depression. And it's all about optimization, because I can do this model, but we have to optimize this. So I'm optimizing this under the depression conditions.
It's absolutely fascinating. The only thing I would change in that is to focus on the hardest part in what you're doing, is recreating the model of our brain. And this is, I think, sorry to say that, much sexier than saying that you're dealing with depression only. Because saying I'm recreating a brain on a chip, this is like mind-boggling, for me at least.
Okay, thank you.
How are you going to prove your thesis? I think about the methodology.
Well, there are many ways to prove it. For the inflammatory states, we will be doing ELISA test as well as the PCR, so confirming some genes connected to the inflammatory states, like EL6 or other. For the neurons, we can check the levels of the ions, levels, but also neurotransmitters like dopamine and others. So the list is long, but for now I have optimized the blood-brain barrier, and now we are focusing on the full neurovascular unit.
Okay, more questions? If not, we almost finish the time slot, so thank you very much for your presentation. Applause, please.
And now, last but not least, Błażej Żyliński from Faculty of Physics.
We shouldn't exist. We shouldn't exist if the standard model, our best explanation of the universe, is correct. Why? Because the standard model covers only 5% of the universe. The rest, the dark matter and dark energy, is completely unknown to us. It's ridiculous. We can't see it, but we know it exists. So how can we find it? Where it is? Many dark matter candidates are incredibly light. Unfortunately, we don't have sensors sensitive enough to detect them. So do we ever know why do we exist? Yes, we will, thanks to quantum sensors based on superconductors. What is the idea? The superconducting state means there is no electrical resistance in the material. If we apply an electrical current into a closed loop of superconductor, the current will flow forever without stopping. It could be the solution. Another fact is that if we break the superconductivity state, we can see a voltage peak inside the nanowire circuit. Even more, we can control this sensitivity. The thinner the wire, the more sensitive the sensor becomes. And sensitivity is that what we're looking for. Superconducting state is very fragile. Fragility means sensitivity, and sensitivity is exactly what we need to detect dark matter. But there is another thing. Superconducting states requires extremely low temperatures, below minus 250 degrees of Celsius. To reach them, we need a liquid helium, which is very expensive. But thanks to advances in physics, we already know few superconductors that work in the higher temperatures, above minus 200 degrees of Celsius. The thing is that we are unable to build quantum sensors built to these materials. Of course, we know already some materials such as YBCO, which is high temperature superconductors. But here we need a hero to make it happen, to build these superconducting sensors. I'm the hero who will do it. Superconductors, my research focuses on superconducting nanowire circuits, which are able to detect dark matter. My research focuses on build this device, and it will apply to many fields, such as quantum physics, such as research of standard model, but also in neurology, even philosophy, because of its extreme sensitivity. And another thing is crucial. If we increase the operational temperature of these devices, it will be game changer for cost efficiency. And that's why, thanks to that, maybe we could finally find the answer to the question, why do we exist? Thank you.
Thank you very much for your presentation. Any questions to our superhero?
If I may. Great presentation, thank you for that. Great opener. We should not exist. It's great.
But we still exist.
We still do, yeah, against all the odds. I was wondering if you're working on creating sensors or discovering new superconductive materials.
I'm working on creating new sensors.
Out of materials that are already there?
Exactly.
Have been discovered by other people?
Exactly.
Okay. And what do you think could be discovered? What do you expect to detect?
Physicists looking, in example, for axions. They are very, very popular in the world of physics. But the key things is that I mentioned about cost reduction. It's really expensive to detect such a thing. But if we reach the liquid nitrogen range, we could build very big sensors, very big matrices of sensors, and try to finally look at stuff like that. So that's the point. The scalability of this solution. Of course, we're looking for some sophisticated technological solutions, but the scalability is the main factor, that those sensors could be bigger, we could build a big matrices of these sensors, and also able to read the impulse. Because another interesting thing in quantum sensing is that they are incredibly fast. The threshold time is 1 picosecond. So it's way, way bigger than the regular one, yeah.
I think that your story was quite well told. I mean, the story, the text, the script was quite good. If I would suggest you to work on something, because I know it's very stressful to be on the stage, and when I'm on the stage performing in front of people, giving short presentations, I'm really stressed. So big claps for all of you here on the stage today, because you did a great job. But it's much clearer, and the emotions pass through to the audience when you use pauses, when you differentiate your voice, so that when you say, I'm a hero, it's like, and I am that hero who's going to do that.
I fully agree.
You know, not saying, and I'm that hero. So you would have to work on that, because the script was great, the story is great, and I almost understood everything. So
I like your feedback. Yeah. Thank you.
Thank you.
I have a question. Did you figure out already the material which you are going to use for your sensors?
There are a couple of candidates. YBCO is quite interesting. We know that it's possible to create very thin layers of YBCO. Mm-hmm. Another, let's say, elephant in the room for the physicist is that YBCO is a second type of superconducting material. So the theory, in example, BCS theory, it's not fully applicable to this stuff. So that's the thing that we have to deal with it. But there are a couple of candidates. Another candidate, but is below the liquid nitrogen level, is magnesium diboroid. And we know that guys from MIT are able to do it, but they don't reach the highest temperature required for this material, because those sensors working in 20 kelvins, but in theory it's possible to reach 39 kelvins. So it's some stuff to do it.
Okay, but your goal, what's the temperature? Minus how many Celsius? There's your goal for your sensors. What's your dream?
My dream is break the barrier of liquid nitrogen, so it's minus 95.8 Celsius. So it's that's the point. Yeah.
Okay. Thank you very much. Questions, comments? If not, the applause for our hero. Thank you.
And this was the last of the heroes of today. So it was the 10th presentation. Thank you very much to all of you. And now I need to say I'm really happy I'm not in your shoes, because now the jury needs to make their decision. So we are a bit ahead of time, which means that it seems we are going to announce the winners around 4:30. If there will be any change, we'll let you know. But now, already in 5 minutes, you can start doing your public voting. So let's release the jury for the hard work that is ahead of them, and then to the rest of you, let's have a coffee break. And meanwhile, before the jury is back, please vote, and also all the people online, please vote too. Notes, not make a hesitant decision. In 2 minutes, vote. Our esteemed jury is back. Okay, so I would like to invite the head of the council, head of the jury, to announce the results. Thank to all of you for your patience. And now,
Yes. So thank you very much for waiting. It was a very difficult decision for us. We discuss each presentation and of course, as I told, to make a decision who will take the third, second and first place was not so easy. But finally we had to decide, so therefore we decided that the third place took Paweł Romańczuk. Okay, so tension comes up. Then the second place goes to Aleksandra Pisarek. And first place. Okay, Natalia Izdebska.
To the special prize, right? Special prize, yes. I have an honor to give the special prize based on the story, based on the communication skills, based on the presentation itself, and the whole thing surrounding the story. And before I tell who that is, I wanted to congratulate you all for giving exceptional presentations. They were all really good. And if you'd like to consult what you've been doing here on the stage, if you'd like to get some more feedback and maybe work on tuning your presentations, I'll be happy to help you. But for presenting a mystical story in an almost perfect way, I'd like to hand over this special prize to Shirayu Monira. It was really a great story and very well told. It was a suicide mission to have that presentation today, but you managed to do it really well. Congratulations.
And finally, we have one more award prize, which is the person which was chosen by the people observing the presentations, so public prize. And after watching final results, it happens that it was Natalia Izdebska. Now it's time for photos. So we have first photos with the jury and with the people, all people awarded. And then we ask all of the top 10 presenters also on the stage, because being in this group, it's also very prestigious. So congratulations again.
Okay, so yes, it seems that's it for today. So thank you once again to the jury for all the work, and to you for taking part in this competition. And thank you for this announcement about the special consultations. Thank you for this declaration. And to all of you also, please look what the doctoral school and also the Bureau of Communication is doing for science communication. So if you think you will almost perfect, but you want to be perfect, or for example, next year you want to be on this stage with those handshakes, please simply follow up, simply ask all us. We can simply provide you with the training if you need it, sometimes with ECTS points. So once again, thank you and congratulations, and have a nice evening.